Hello everyone, myself Shivakrishna, Assistant Professor in FME department in St. Martin's Engineering College. So my topic is single phase transformer. First of all, what is transformer? So transformer is a static device, means it is a constant. It is a constant device like a fixed device. So basic principle of transformer is it transfer electrical energy from one winding to one winding to another winding without changing frequency. So it's called transformer. So first of all, we have discussed these topics. What is transformer and structure and working principle of transformer and construction of transformer and losses in transformer and ideal versus practical transformer and uses and applications of transformer. So first of all, we have discussed basic introduction of transformer. So transformer basic principle, it transfers the energy. Basically transformer having two windings, primary winding and secondary winding. So primary winding we are giving the input voltage supply and the secondary side we are connected to the load side. So primary side whenever we are giving the input supply, then automatically it is working on the mutual induction principle. So mutual induction principle means it transfers primary to secondary without electrical supply, but mutual induction means it is interlinking the flux both primary to secondary. So primary side, so this is the basic introduction to the transformer. And next slide is, so what is transformer? So already we have discussed transformer having two windings, primary winding, secondary winding. So primary side current is I1 current and the secondary side current is I2 current. So primary side number of turns is N1 number of turns and the secondary side number of turns is N2 number of turns. And the primary induced EMF E1 and the secondary side is induced EMF is E2. So that is the basic structure of the transformer. So this is the volt type diagram. So transformer. So this transformer having 2 is the input side and 2 is output side. So for example, these two pins is we are connecting to the input terminals. These two terminals we are connected to the output side terminals. So this is the volt type transformer. So this is the core. So core is iron core is. So this is the lifting purpose. This we are used. So this is the basic diagram of the volt type transformer. And next, structure of the transformer. So structure means, so transformer basically having two windings. First one is primary winding and secondary winding. So these are not connected to the circuit level. So these are connected to the mutual induction principle. So mutual induction principle. So this is the practical diagram of the transformer. So this is the practical diagram. So basically transformer types is two types, step up transformer and step down transformer. So how do we are consider step up and step down? So step up means we are used to generating station levels, generating stations we are used to the step up transformers, and step down transformers we are used to the distribution purpose and utilization purpose like substations like that. So these are all used to the step down transformers. So this is the basic practical diagram of the transformer. In this diagram, we know that the primary winding, this is the coil, magnetic coil wound. So this is the iron core of the transformer. So it is laminated with to reduce the leakage flux. To reduce the leakage flux, these dotted lines are denoted to the magnetic flux. It is interlinking the primary to secondary. Whenever we are giving to the supply on the primary side, then automatically induced EMF is connected to the secondary. That secondary side we are connecting to the load of the transformer. So this load we are used to the domestic levels, industrial purpose, commercial purpose. We are used this type of transformers. And next, working principle of the transformer. So main working principle of the transformer is electromagnetic induction principle or mutual induction principle. Electromagnetic or mutual induction principle means primary to secondary, not connected physically, but we are connecting to the whenever we are giving to the supply on primary side, then automatically interlinking the secondary side of the transformer. See the basic diagram of the transformer. For example, so transformer, so see the transformer basic diagram. So this is the transformer. So it is shape of transformer is a rectangular or square shape of transformer. So this is the primary winding. So this is the primary winding, and this is the secondary winding of the transformer. So secondary winding we are connected to the always load side. So this is the load of the transformer, and this is the input side voltage and primary current I1 current, and secondary current is I2. Primary side current is I1 and secondary side current is I2. So it is whenever we are giving the supply on primary side, then automatically induced EMF will connected to the primary to secondary. So this is magnetic flux with help of iron core of the transformer. This iron core laminated the transformer core layers, different layers, laminations. So voltage induced EMF E1 primary side induced, and the secondary side induced EMF is E2, and the primary side number of turns N1 and the secondary side number of turns is N2. So this is the basic construction of the transformer. So this is the basic construction of the transformer. So transformer basically already we have discussed step up type and step down type. Step up transformer and step down transformer. So see the what is step up. So first one, step up transformer. So step up transformer, see the basic diagram of the step up transformer. So again a rectangular shape of transformer, rectangular. So this is the rectangular shape of transformer, input side. So voltage connected, current is I1, and step up means secondary side coil turns is high. Step up secondary side coil turns is more number of turns compared to primary side. So this is the we are connected to the load side. So automatically mutual induction principle working, interlinking the flux. Mutual induction principle interlinking the flux. So this is the primary number of turns is N1, secondary number of turns is N2. So step up means N1 is less than N2. N1 is less than N2, means here N2 number of turns is more compared to the N1 number of turns. N2 number of turns is more compared to the N1. So this is the step up transformer. This step up transformer we are used at generating stations. Generating stations, we are increasing the voltage levels. Increasing the voltage levels up to generating stations generated 11 kV or 13 kV. That voltages we are increasing using with step up transformer up to our requirement 132 kV or 220 kV depending upon our requirement. 132 kV, 220 kV up to 11 kV to we are increasing the voltage levels. We are increasing the voltage levels using with step up transformers. So basic major principle is N1 is less than N2. So this is the step up transformer, and another one is step down transformer. Another one is step down transformer. See the step down transformer, similarly it is here draw the rectangular or square shape of the shape of the iron core. So step down means we are decreasing the voltage levels. So decreasing the voltage levels means N1 greater than N2. N1 greater than N2. So N1 means number of primary turns. Number of primary turns is more. So see the diagram. So this is the primary winding connecting the voltage side. So I1 current, and similarly secondary side less number of turns compared to the primary winding. So this is the load side I2 current. So mutual induction in principle or electromagnetic principle, both are interlinking the flux primary to secondary. So this is the step down transformer. Primary side is more number of turns and the secondary side is less number of turns. So what is the basic principle? N1 greater than N2. N1 is greater than to the N2. So this is the step down transformer. So what is the applications of the step down transformer? So basic applications of the step down transformers, we are using the substation levels. Substations like transmission side, transmission and utilization purpose. Utilization purpose, we are using the step down transformers. So this is the basic diagrams of the step up transformer and step down transformer. So this is the transformer, single phase transformer. So basically basic transformers, supply side. Supply side we are discussed single phase and three phase. Supply side transformers we are discussed total two types, single phase transformers and three phase transformers. Single phase transformers we are used at a domestic level purpose. Domestic level purpose. And three phase transformers we are used at a industrial purpose. So industrial purpose. So this is the differences between the single phase and three phase of the transformers. So this is the basic information. So how to work transformer and how many types of the transformers and how many subtypes of the transformers and principle of the transformers. And next we are going to the PPTs. So already we are completed at so introduction of the transformer and the principle of the transformer is over. Now we are discussing the types of transformers also over, and next one working principle of the transformer. So working principle of the transformers, so working principle of the transformers, mutual induction principle. So this is the mutual induction principle of the transformer. So see the basic diagram. So primary winding and secondary winding. So this is interlinking the flux of the transformer, magnetic flux. So input side we are giving the voltage. Which voltage we are giving? The AC voltage. AC means alternating current only. Alternating current only we are connected to the transformer, not connected to the DC. Not connected to the DC. Only transformers we are used at AC purpose, not in DC. Okay. So this is the basic information. So mutual induction principle. Mutual induction principle, primary to secondary. Mutual induction principle. This flux is connected to the secondary side. The secondary side cuts the EMF. Then automatically the secondary side connected to the load. This load we are used single phase transformers, always used to the domestic level purpose. So this is the next diagram of the transformer and construction of the transformer. Construction of the transformer, majorly magnetic core and windings or coils. Magnetic core and windings and coil. So before see the basic video of the transformer. So how to work? basic video of the transformer. So this is the basic construction of the transformer. Basic construction of the transformer. So this is the laminated iron core, number of layers, formation, this transformer, and next one. So this transformer having total core, windings and insulating materials. So this is the primary winding and secondary winding of the transformer. So this is the wax paper in between the primary winding to the secondary winding. Wax paper we are connected to the in between the primary to secondary. So this used to the insulation medium purpose. Insulating medium purpose we are used the transformers. So these transformers, these are the next point is transformer oil. So why are using transformer oil? Cooling purpose. Cooling purpose we are used the transformer oil. So this transformer having total shell type of transformer. This shell type of transformer total having 3 limbs. 3 limbs means this is the first limb, both are outer limbs, and this is the middle limb, central limb. So each limb connected the primary winding in internal side and external side connected the secondary winding. So this is the central limb and similarly outer limb. 2 are outer limbs and middle one is the central limb. So this top of the 3 bushes is there. Bushes are insulators. These insulators were connected the load side. These insulators were connected the load side. So this is the internal part of the transformer. So this is the tap changing level. This is the tap changing level. What is the tap changer? Tap changer means depending upon load, high load and low load. So high load daytime we are used high load. So this is the used to the maximum level. We are increasing the maximum level of the transformer, and low voltage level we are used at nighttime purpose. Nighttime purpose we are decreasing the transformer because nighttime purpose we are used only low voltages. So that is the tap changer. Next, conservator tank. So this is the conservator tank. This conservator tank inlet of the oil. So inlet of the oil, cooling purpose and pressure purpose. So pressure means load is high, then automatically oil will be increased, oil level, and load is low, oil level decreased. So increasing and decreasing depending upon load of the transformer. And next, breather. So breather, here breather we are used to material silica gel. Silica gel material to protect the external forces of the atmosphere to the transformer. And next, cooling tubes. So these are all cooling tubes both side constructed both side of the transformer. So cooling purpose these cooling tubes are used. Next one, Butch hose relay. So this is the Butch hose relay. Whenever fault is occurring in a transformer, this Butch hose relay automatically ringing, we are rectify the problem. And next one, explosion vent. So this is the explosion vent. Whenever transformer internal side pressure is high, and then automatically explosion vent is used automatically. So this is the basic construction of the transformer video. This is how to work and how to use. We are using the individual parts, core part and windings, insulating materials, transformers and tap changers, conservator tank, breather and cooling tubes and Butch hose relay, and finally explosion vent. So this is the construction and working of the transformer. Basic diagram. So this is the basic diagram of the single phase transformer. And next one, we are going to the main types of the transformer. So main types of the transformer. So basically types of the transformer, main types of the transformer, core type transformer, and next one is transformer. Next one, transformer types we are discussed. Core type and shell type of transformer. So what is core type transformer and what is shell type transformer? We are discussed. So core type transformer is So see the differences between the core type and shell type of transformer. So this is the shell type of transformer. So shell type of transformer, these are the lamination. So lamination letters is E letter and I letter, E and I letters. So this is the shell type transformer we are used. And core type of transformer, core type of transformer we are used the letters L type letter and U type letters. So these are the stampings of the transformer, core type and shell type stampings of the transformers. And so this is the laminated core to reduce the leakage current, to reduce the leakage current or leakage flux of the transformer. So this is the laminated, each one laminated square shape transformer. Okay, and next one is shell type of transformer. So basically shell type of transformer, this is the diagram of the shell type of transformer. So these are having total 3 limbs. So this is the 2 is the outer limbs and middle one is the central limb. These 2 are outer limbs, this middle one is the central limb. So this central limb we are connected the primary winding internal side and secondary winding we are connected the external side. So this is the P1 and primary side and P2 another primary side, S1 secondary side first one and S2 is another secondary side. So these are the windings of the transformer. These shell type of transformers we are used at high voltage levels. High voltage levels we are used the shell type of the transformer, high voltage levels. So high voltage levels we are used the shell type of transformers. And next one, core type of transformer. So this is core type of transformer, rectangular shape. So this is the rectangular shape of the transformer. So number of layers laminated is there, laminations. These laminations we are reducing the leakage flux and magnetic flux of the transformer. So whenever we are giving the supply, always primary side, so then automatically using mutual induction principle, mutual use the using core primary to secondary, move the flux, EMF will be induced in secondary side, then EMF is secondary side EMF connected to the load side of the transformer. So this is the LV insulation and next HV insulation, and LV winding means low voltage winding and high voltage winding of the transformer. So these are the number of laminations connected the transformer, laminated core. These are the laminated core, E core, E shape and I shape of the transformers. So this is the core type transformer and shell type transformers, basic laminations and basic diagrams of the transformers. This is the core type of the construction of the transformer. So already we have discussed the shell type and core type. So this is the number of layers of the transformer. So this is the layer 1, number of layers, and each layers one by one it sandwich the number of layers. So compress the number of layers. So this is the layers of the laminated layers of the transformer. And next one, shell type of transformer, basically we are used at high levels. High level voltages means industrial purpose. So these transformers we are used at industrial purpose. We are used these shell type of transformers. So and core type of transformers, low voltage applications, like low voltage means housing purpose, domestic purpose. These type of purpose we are used to the core type of the transformers. So this is the high voltage applications purpose and low voltage applications purpose. So low voltage application purpose we are used the high voltage and low voltage shell type and core type of the transformers. And next one, major part of the losses in transformer. So basically losses in transformer, copper losses and iron losses. So copper losses, how to occur copper losses? It is similar to the windings, two windings. So already we know that transformer having two windings, primary winding and secondary winding. So primary winding current to resistance due to the occur the primary to secondary of the transformer. So then magnitude of the copper losses depending upon the current flowing through these coils. So basically these coils are where a representation of the transformer rating is a combination of voltage and current. Voltage and current. So voltage and current, it is rating, transformer rating kilovolt ampere. Transformer rating is kilovolt ampere. So we are kilovolt ampere means 33 kVA and 66 kVA and 132 kVA, 220 kVA. We are representation of the capacity of the transformers we are using. So this is the losses of the transformer. Copper losses occur in current in primary to secondary, and iron losses in occur in voltage level and primary voltage to secondary voltage levels. So this is the losses, copper losses and iron losses of the transformer. And next loss is third loss is hysteresis losses. So hysteresis losses occurring magnetized and demagnetized, magnetized and demagnetized in a two windings of the transformers. These loss occur in core side. These loss occur. So magnetizing and demagnetizing. And next one, final loss is eddy current loss. So eddy current losses leakage magnetic flux of the EMF core produces. This is the iron core of the transformer. So this is the winding of the transformer. So this is the iron core. In this iron core, magnetic flux is there. This magnetic flux, eddy current losses will be induced. Eddy current losses will be induced in a transformer. So this is the eddy current loss of the transformer. And next one, ideal versus practical transformer. So basic ideal transformer is there is no loss, there is no losses in ideal losses, and windings in resistance is 0. So there is no leakage flux, in ideal transformer. There is no leakage flux in ideal transformer, but a practical transformer having little bit of losses. Practical transformer having little bit of losses. Like losses means flux loss, flux leakage, and current losses, small magnetic field. So these are the losses of the ideal versus practical transformer. So next one, basic applications of the transformer. So majorly we are using the transformer low voltage applications and high voltage applications. High voltage applications we are used domestic purpose applications and industrial purpose applications. And low voltage level applications we are used at electronic devices. Electronic devices like means televisions, photocopy, and next signaling, radios. So these are all low voltage applications, electronic devices we are used, and high voltage applications we are used domestic purpose applications and industrial purpose applications we are used the transformers. So this is the main applications of the transformer, and the transformer more today's essential part of the transformer, because transformer is to reduce the voltage levels. That voltage levels we are used like fans, our housing purpose, lights, etc. These are all using with we are step down the voltage levels, then automatically we are using the domestic purpose and industrial purpose. So this is the major applications and uses of the transformer. So this is the overall concept of the transformer, single phase transformer, and similarly it is related to the three phase transformer also. So this is total working and construction of the transformer. Thank you.